You know that image we all have of a scientific breakthrough, some brilliant mind, totally isolated, maybe on an island somewhere, and then, bam, a sudden flash of insight. That's the classic image of the lone genius. But what if that romantic ideal is just plain wrong? In this explainer, we're going to pull that whole myth apart.
All right, so here's our roadmap. First, we're going to dig right into this genius myth. Where did it even come from? Then, we'll hit you with a surprising truth. Scientists are just as biased as you and me. So, if that's true, how does science actually move forward? Well, we'll look at the power of a really good argument and what we're calling the argumentative engine that drives discovery. And finally, we're going to put it all to the test by revisiting a very famous genius and exploring the incredible power of social context.
Okay, first up, the myth of the solitary genius. Let's start right at the beginning. Where on earth did we get this powerful, almost romantic idea of a brilliant person working in total isolation?
I mean, this line from the poet Wordsworth just nails it, doesn't it? It perfectly captures that romantic idea of the genius. He paints this picture of Isaac Newton's mind as something totally unique, voyaging through strange seas of thought alone. It's such a powerful image, and man, has it stuck with us.
And here's where that poetic image gets turned into an actual model. In this solitary genius view, the great mind is basically fed data, they retreat into their own little world, and then they pop back out with a complete, perfect theory. It's a really neat and tidy picture, and you know what? It's incredibly similar to a vision for science that was laid out centuries ago.
Yeah, that vision came from the philosopher Francis Bacon. He imagined science as this highly structured pyramid. Down at the bottom, you had your collectors who gathered data and your experimenters who tried new stuff. But way up at the top, the real deep thinking was saved for this tiny elite group he called the interpreters of nature. And in his system, there was absolutely no room for debate among equals. The genius was just set apart.
But here's the thing. This neat, tidy, hierarchical model has a huge problem. It totally assumes a level of pure objectivity that, well, might not actually exist, not even in scientists.
This pessimism was famously put into words by Max Planck, one of the founders of quantum physics. He got so frustrated by people resisting his own revolutionary ideas that he came to a pretty bleak conclusion. He basically said, a new scientific truth doesn't win by convincing its opponents, they just eventually die. He truly believed that scientists were so stubborn that progress could only happen once an entire generation was gone.
And this brings up a really crucial question. For that whole solitary genius model to work, scientists would have to be some kind of special breed, totally immune to the biases that mess with the rest of us. They'd need to be completely shielded from stuff like my side bias, that natural human thing where we just love evidence that confirms what we already believe and we find any excuse to dismiss stuff that challenges us.
So are they?
Well, some experiments back in the 1970s by a guy named Michael Mahoney put this to the test. He compared different groups, and get this, he found that physicists and psychologists showed just as much my-side bias as Protestant ministers. The scientists were just as biased as everybody else, even when they were reasoning about their own fields.
And this isn't just in some controlled experiment. A researcher named Kevin Dunbar actually went into real labs to watch scientists do their thing. And what he found was that when an experiment failed, their first instinct was never to question their own precious theory. Nope. As you can see here, it was to blame something else. The equipment must be faulty, the procedure was flawed, anything to protect that original idea.
Okay, so if individual scientists are just as biased as the rest of us, but science as a whole obviously makes progress, there has to be something else going on. There's got to be another mechanism at work here.
And look, to be fair, you can understand the skepticism. Science often presents these incredibly weird, counterintuitive ideas. We're asked to just accept that we came from single-celled organisms, that we're all hurtling through space on a giant rock, and that our entire consciousness is just the product of a 3-pound slab of gray stuff in our heads. I mean, these are not easy things to just swallow.
This brings us to a really interesting counterpoint from the historian Thomas Kuhn. He studied scientific revolutions, and he came to a much more optimistic conclusion. He argued that despite Planck's pessimism, and yeah, while some scientists might resist forever, most of them can be reached in one way or another. In other words, they are open to being persuaded.
So here's the showdown. You've got Planck, who saw progress as generational. You just have to wait for the old guard to die off. And then you have Kuhn, who saw progress happening within a single generation, through people being converted by good arguments and solid evidence. And the funny thing is, history pretty much proves Kuhn was right. Even Planck himself lived to see his own revolutionary quantum concepts get accepted and used by his peers.
And the history really backs Kuhn up. Just take Darwin's The Origin of Species. I mean, that's arguably one of the most world-shaking ideas ever put to paper. Within just 10 years of it being published, a whopping 75% of British scientists were already at least partly convinced. That's not waiting for a generation to die. That is a full-blown revolution happening in a single decade.
And that's not some one-off thing either. We see the exact same rapid change with the theory of plate tectonics. As soon as a convincing model was presented, it only took about a decade to completely rewrite the geology textbooks. The evidence is pretty clear. When the arguments are strong enough, science can change, and change remarkably fast.
So here's the million-dollar question. What is it that drives this rapid change, especially when we know individuals are so biased? What's the engine? Well, the answer seems to lie in the power of collective discussion.
Let's go back and look at one of the very first scientific groups, the Royal Society. Now, its founders were brilliant, for sure, but they also believed in some pretty wild stuff, like astrology and occult healing. Their single most important contribution wasn't any one discovery. It was a whole new method for finding knowledge. A method based on doing real experiments, having open-ended conversations, and valuing new information over dusty old texts.
Thinkers like Robert Boyle, who was a huge figure in the Royal Society, really pushed for a brand new way of using dialogue. For someone like Galileo, dialogue was just a tool for a genius, a mouthpiece really, to explain a truth they'd already figured out. But for Boyle, dialogue was the process where truth emerges from the conversation itself. Nobody starts out knowing the answer. You discover it together.
And this process is totally alive and kicking today. Remember those scientists from Dunbar's study? The ones who tried to explain away their failed experiments? Well, when they brought those weak excuses to their lab meetings, they got shot down. The other people in the lab rejected the easy excuses, they brainstormed other possible explanations, and they forced a better, stronger understanding to emerge from that group discussion.
And this isn't just some historical observation. Scientists today absolutely live this reality. As one mathematical physicist put it, science is a gregarious business. He said, it's only by interaction that you get anything interesting done. It's a communal enterprise. It's all about the community.
Okay, but what about those giant figures in history who really seem like the exceptions to the rule? What about someone like Werner Heisenberg? You know, the guy who supposedly came up with the uncertainty principle all by himself while isolated on an island?
Well, when historians take a closer look, a very different story emerges. Heisenberg's incredible achievement wasn't a solo act at all. It was more like a creative coalescence of different arguments. His work was a reaction to Schrödinger's ideas. It was built on concepts from Bohr and Dirac, and this is key. It was sharpened by constant, intense challenges from his colleague Wolfgang Pauli. In fact, the very first draft of his legendary uncertainty paper actually shows up in a letter he wrote to Pauli.
So what this really means is that even the act of thinking alone in science is fundamentally a social activity. Scientists are always in a dialogue, even if it's with an imaginary room full of their most skeptical colleagues. They have to constantly anticipate the counterarguments, and that process forces them to find arguments that are universally valid, not just arguments that sound good to themselves.
So for our final section, let's look at the ultimate test case for the whole solitary genius theory, the man who started it all, Isaac Newton himself.
Because here's the thing. While Newton was producing the absolutely brilliant physics of his Principia, he was also spending years and years writing hundreds of pages of really obscure and ultimately useless alchemical notes. They were filled with passages just like this one, trying to decode weird allegories about dragons in ancient texts.
So what was the difference? It wasn't his brain, it was the social context. For his physics, Newton had to convince a community of brilliant, skeptical peers, and that forced him to create these beautiful, tight mathematical arguments. But for his alchemy, he worked almost entirely in secret with very few people to argue with, and his work was never even meant to be published. One path led to world-changing science, the other led to a complete dead end.
And that right there is the ultimate lesson. The solitary genius, when they are truly solitary, can get completely lost. Newton's brilliant mind produced world-changing science only when it was being sharpened by the constant pressure of a skeptical community. The moment that social pressure was gone, that same mind went down a long, fruitless rabbit hole.
And all of this leaves us with a final and I think a vital question.
If we accept that real progress doesn't come from isolated geniuses, but from open, honest argumentation within a community of skeptical peers, then how should we be structuring our efforts to solve the most complex and urgent challenges we're facing today?